Good morning, everyone. Good morning. It looks like, yeah, Patricia, you beat Hades. Morning, Patricia. Morning, Hades. You got the first spot. You tried. Nice. Well, happy Sunday. And good morning to you, whether it's morning, whether it's afternoon, or evening. Welcome to the SOC 100 stream. This is SOC 100-1. We are back. We're going to do more networking today. We're going to be going from ping all the way to Nmap. That's the goal today. Let's see if we can make it there. We got a lot to cover. A lot of hands-on content now. And I think we'll also squeeze in a little bit more room for a little bit more theory along the way. Kim, morning. KS. Yeah, they beat you to it. R double. Top of the morning. Pariah. Going. CI. Good to have you back. I think you like the yeah, yeah, it's right, Cass. So I got one emote. Yeah, I finally I was messing around with it last night, trying to figure out all of the different Twitch affiliate settings. So now there's like level effect points on the bottom that you should be accumulating just by being inside of the channel. And Hades, yeah, you've got the founder first. I think there's only a limited amount of like the first subs. I don't even know how I can control that. So you're up there. You are a founder of Level Effects Twitch channel. It's pretty cool. Yeah. Oh, it's top 10? Is that how it works? Okay. It's pretty cool. Yeah, I've got one level effect emote, and then I need to create some emotes for subs as well. I've got some things I need to figure out on this side. So if any of you have any requested emotes, just send them over. Let me know in Discord. Nice, Cap. Thank you. Thanks for the sub, man. Welcome. You should now be a defender. It says that somewhere, I believe. You are now a defender of effect. So I've got a little bit more Twitch moderation to do as well. More emotes. Those little things that pop up and stuff. So yeah, it's really appreciated. Seriously, everyone, I really do appreciate it, because after SOC 100's done, and even before that, actually, we are going to be doing more streams just outside of SOC 100. There's a lot of stuff that we have in mind to do. They don't necessarily need to be 4 hours. They can be like a 45-minute, 1.5, 2 hour kind of thing. But liking the platform, it's good, easy for delivery. The recordings are good quality. They pop up right away for me to do edits afterwards. So all of that works out really well. So we definitely intend to continue doing this. Really enjoying it. There's a whole lot of content we can cover. Like I said yesterday, I would love to just do like a couple episodes just like on packet tracer, configuring networks, so you can see all of that. There's a lot of the infrastructure as well too, like building out the whole home lab and like really fleshing it out like a home virtual SOC. That'd be really cool. So yeah, appreciate everyone being here and being part of this. Definitely want to keep doing this. Hades, you were 4 to 5 years mod in a partnered stream and also coded. Oh, that's pretty cool. Yeah, that is very, very cool. I would definitely love a little bit of advice. I might pick your brain in some questions, because I wanted to get a Twitch bot as well that could just like respond to things. Yeah. I need to set up those like little exclamation things where people can ask questions. Lots of that little stuff. Cool. I'm gonna pick your brain after Hades. And then I think eventually we'll open up some ability to have mods on the stream as well too, and give you all back something for being able to do that. TBD. CI, do you have to buy equipment to set up a home lab? Not necessarily. I mean, if you really wanted to, you could go and, like, if you go on eBay, or even like Facebook Marketplace or Kijiji, something local, you might find companies tossing out old equipment that's like old, but it's still perfectly functional. So you can go and find like an old switch or an old router and then kind of set up that like your own physical hardware. Otherwise, if you have at least 16 gigabytes of RAM on your system, you could build out a pretty decent small home lab. 8 gigabytes would be really pushing it. You could probably just do like one virtual machine at a time. But 16 gigs is enough to actually build like small server, maybe 2 workstations, and kind of give them some limited resources for them to be able to interact with one another. I'm also going to test something. I want to set up this alert notification box. Are you guys seeing like notifications pop up on the stream? Like when someone follows or something? Let me know. You are, okay. Because I'm not seeing it, which is really throwing me off. That's... Go take a look. Do some more digging. I might do like a midweek test stream as well at some point, just maybe this week or next week to do some more configuration stuff. Edu Moriam. Morning. So eBay can be a great, yeah, it can be great for bargains. Picked up a Dell R730, 2 8-core CPUs. Wow. 128 gigs of RAM too, and 4 terabyte storage. 200, wow, that's not bad at all. Yeah. Yeah, eBay, like, just, and so companies have to go and replace their hardware, like, every, depends on their actual cycle. Some do 3 years, some do 5, some do 7, some just really wait till end of life, which is, can be like 10 years. So, typically you can find perfectly good working hardware for a home lab for super cheap like that. Or just people tossing it out on Facebook Marketplace, or just, like, covering, like, the recycling fee, which may be like 50 bucks. So if you really want, you can build like a nice, cheap home lab. So CI is saying it used to be a banner that popped up? Yeah, it should be. It should be a banner that's popping up. I need to find out. I'm actually going to open it up on my iPad and see what's going on. Let's test this out. Seeing it on the... Yeah, cool. Eric, thanks for the sub as well too. Appreciate it. Welcome. You're now a defender of level effect. Yeah, you didn't see notification. Yeah, I'm not sure. They are on. For whatever reason, doesn't seem to be working though. I need to go and find out why. There was something but not a whole... Oh, you heard a sound? Yeah, that was me. I'm on the back end here. I'm trying to figure out like my alerts. Like it shows it working. It says it's all configured, but for whatever reason... Nice. Well, Eric, welcome to the team. You are now a level effect defender. Promise I'll get you all set up with some better emotes and reactions and things soon. Gonna get that done this week now that we can actually do it. So yeah, you're now like a first founder, and then I think you have access to one emote as a sub, so you can actually drop that over there. I think. Nice, cool. Good stuff. Thank you for being here. Thank you, everyone. Thank you for the subs and follows and just supporting the stream. Really appreciate it. So, let's do this. Let's do some networking. Let's network together. Let's make this all work. Jay's here very early for you. Welcome. Thanks for waking up. Thanks for being here, waking up early with everyone. Lab time. Alrighty. So let's see where we're at. Today we're gonna go from pinging to DNS lookups. We're gonna do some curls together. So for those of you that like working out virtually and don't like the gym in person, well, we're going to be doing some curls together online, and we're going to look at some other ways to interact with downloads and files via the command line with wget. We've got SSH connections, look at SCP, so we're going to learn how to perform some secure copying through a little SSH tunnel. We've got network shares we're going to be trying to map with SMB protocol. A little bit of port inspection using local network services or network service scanning. So remember when I said back in the command line module with Linux and Windows is we just reserved all of the networking command line activity into the networking module instead of just shoving that into the Windows and Linux modules, because we're more focused on just like learning the operating system and administration. So now we actually get to use some of those networking command line tools. We're also going to look at Netcat, which is super cool. And we're going to see if we can connect our very own personal chat messenger service between two systems. And we're going to learn how to network scan with Nmap, like Trinity did, hacking in the Matrix. Legit, she actually did that. And I think we'll be able to touch base on Wireshark today as well. I think. So the plan is to get through that and maybe at least get to ARP and actually looking at like the ARP protocol in action and doing some packet inspection and MAC address lookups and such. So that's that over here. So cool. Any questions on that? Anyone excited? I'm excited. Yeah. All right. Okay. Green all set up here in my back end as well. KS has been dying for the lab action. He loves it. Okay. Let's get our virtual machines powered on. So we are going to be using Windows and Linux for this. And again, if you're doing this at home, like if you have your own home labs and such, you can just set up your own Linux and Windows workstation, or even if you just have like a laptop and a PC, you can do this as well too. Everything that we're going to be able to do together here on stream with our virtual machines, you can do locally as well too, which I encourage. I want you to be able to Do that. And yeah, CI, we're going to start off in Linux. So we are starting now the SOC 100-1 prepare lab pinging and DNS lookup. So now we actually get to see this stuff in action, especially like those DNS records. Let's give that a minute over there to connect in the meantime. Yeah. Yep. Got the logo on today. It is a big day. Okay, so that should be connected now. See the little connect button pop up. So let's go ahead and do that. I'm actually going to Windows 2 at the same time. So Windows tab, Linux tab. All right. So first things first, we are going to open up a terminal on Linux. There we go. I don't know why that took so long. Let's open up a terminal. You can do the same thing on Windows as well, just for now. Leave that on the side. And what we want to introduce first is the ping command. So a little what is ping over here. And what ping actually does is it sends an ICMP protocol. Okay. So remember, everything now is going to be like protocol this, protocol that. If you're ever unsure, you can always do like a quick lookup, kind of get an idea about things, but I'll explain them as I go. So we are dealing with the Internet Control Message Protocol. And this specific protocol actually sends a request. It sends an echo request to a specified IP address. And this is effectively just a method for checking connectivity. That's what ping is. And if you're not sure what that kind of means, like imagine just like poking someone, you know, like imagine like you and your friend are waiting in line or something, trying to pull a prank, and you just like tap them under the shoulder, and then you laugh as they turn around and no one's there, you know, because I think that's funny. Maybe not everyone does, but anyways, so imagine like you just like poking someone to get their attention. That's effectively what it's like. So we're gonna send a echo request, and this is under the ICMP protocol. And what it does is it will deliver itself to the other host, and it goes down with the OSI model up over on their side as well. And each time the ping is successful, we'll receive an echo reply. So an echo request goes one way and an echo reply comes back to us. And if we get the echo reply, that means that the connection is live, at least in this sense. Now, sometimes hosts can actually disable ping. And that's actually kind of common because ping is a very lightweight method of scanning and interacting with another endpoint to see if that endpoint is up. Remember yesterday we talked about the notion of Ethernet adapters being up or down. And up essentially means this is a live connection. You can connect back and forth. That endpoint is alive on the network. So ping is a lightweight way to be able to do that. But it's also a little intrusive. And truthfully, it's not really necessary. And when we're talking about security, we are trying to reduce the likelihood of that actually being detected. It's not detected, but we're trying to reduce the likelihood of someone trying to detect hosts on our network. as much as possible. Like, we're trying to keep things hidden, secure, segregated, and so that's why sometimes you'll see something like ping being blocked. We can just disable the ability for ping to be sending an echo reply back. And that's what happens. So if I were to go and try to ping like some random IP address, just for example's sake, you can see nothing is going to happen because I'm not getting a response. So it's just kind of like floating out there inside of the ether. And the things that can block ping are typically like firewalls and security groups. You know what I think I will do too? Try something. That. Let's actually zoom in so we can have like a little play-by-play of things going on at the exact same time together. Oh, that's going to be kind of handy. This way we're going to be able to see like sort of a visual as we go along. So what we're trying to do here is we have our Linux. And we're going to be trying to send a echo request to Windows in our network. So let's go ahead and we're going to hit Control-C. Control-C to break out of it. And now the Windows side of things, we can go and take a look at ifconfig. ipconfig, see? I do all the time. ipconfig, if I can type this morning, put the Apple Pencil in my hand. Go. Okay, so we're looking at 10.0.19.153. Copy that. So watch the difference now. This is a little different. You could hit Control-C to stop it because it will actually continue. So there's a couple things going on here. We can see that we are receiving 64 bytes from our Windows IP address, and we can see an ICMP sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9 to indicate echo request and also the echo reply coming back to us. So there's also this notion of like the time over there. You can see we have a timing of like 1 millisecond, 0.6, and that's actually kind of important to pay attention to. So effectively, if that's strange, like if it takes a long time, then we can maybe indicate that there's a bottleneck going on. And this notion over here of the TTL, remember I mentioned yesterday, we're going to see time to live. And time to live is, for all intents and purposes, a counter. And now it starts at different values. These can be configured in various different ways for different protocols. But every single time this echo request hits another node, that TTL, that time to live, will be reduced. And then when we get it back, it's also going to start being reduced from the other way. Now, this should effectively always be the same. If I were to ping a host and it said TTL 128, and then the next day I pinged it and it said TTL 40, like, that's really, really weird. Really, really strange. Because that shouldn't be reducing, like if my network is expected to behave the same. And so every single time it's passing through a node, and remember, we're dealing with IP addressing, so this goes up to layer 3, so we're dealing with routers. If we're inside of a switch-based network, local area network, that should always be static, because we're dealing with MAC address routing. Pinging is only going to be reduced in TTL once it passes through the router, and we start seeing some reduction in that number. Bells, afternoon. Thanks for being here. So Now, what's actually happening back is 1, step 2, now Windows. TTL doesn't deal with dropping packets, no. It's just a counter. It's a piece of the data that's encapsulated, and it's just a value. Now imagine every single time that an ICMP request has to go through a router, the router will say it's going to take one count off. And that lets you know as an IT administrator or security analyst that every time that number goes down, the ping is going through another node. And in this case, a router. And what you need to know, if the TTL ever hits 0, like if it drops down to the point where it's going through too many nodes, then it will just be discarded. So let's see if I were to do something like this instead. Let's go outside of the network. Let's see if I can even get out. And then what I'm trying to do right now is I'm trying to ping Google's DNS servers. I know that number just by own reference. So we're not actually going to be able to get out of the network. See? So sometimes your network configuration will be configured in such a way that you can't do that. And then you're going to have outside servers that will disable it. So that's a very different story. And I let it run for a little bit. 43 packets were transmitted, 0 were received, 100% packet loss. Now, if I were try to ping from one subnet to another, then I might see like the TTL dropping like 127, 126, 125, etc. The timing is going to increase substantially. And if there's something wrong, this packet loss number will go up. So pay attention to packet losses. That's what we're looking for inside of ping. And then Hades, yeah, if you ping the next day, I would say not even necessarily man in the middle. Like it doesn't always have to be man in the middle, but it could just mean that your network is failing in some way. Maybe something isn't routing properly. Maybe an IP address got moved to a different subnet. I wouldn't just assume right away it's a man in the middle attack. It doesn't always have to be a man-in-the-middle attack. I mean, honestly, more often than not, yeah, it's going to be more like network issues, latency, like, and that's like the delay. So, there's that. Okay, so that's effectively ping. So again, as a troubleshooting assistant, ping is sort of like your first thing that you go to. Like, if you can't connect to another host, ping it. And if you can't ping it, it doesn't mean that it's not there, but it's an indicator. So it's just part of your connectivity testing toolkit. Now, we can actually set this up to ping in limited amounts because you can see it's going to kind of run on forever. And this is common. Like if maybe you're doing like a server reboot and you just ran a patch, well, you're probably going to want to leave that thing pinging to make sure that you know it came back up. Sometimes it doesn't. So ping, and we can actually throw a taxi over here for like count. And let's just say we're going to ping for like a count of 5. Now it's going to count up 5 pings and good to go. Now we can do this the same way from Windows. So let's kind of do IP address, show ENS5. Remember yesterday we had our IP address over here. So this is what we're looking for to be able to ping from the Windows side. Let's go and ping that. And you can see it's effectively the same thing. Now Windows has a bit of a different setup. You can see it's 64 by default. Over here from the Linux side, it's different. I wouldn't worry too much about these types of differences. These can be configured in the ways that you prefer. What's more important is the number changing. It shouldn't change if your network is optimal and running with your intended design. So you can see there's just always like these little minute differences between Linux and Windows. Gonna stop. Let's take a look at the next setup. All right. So let's go move now over to, I think that was the first couple steps over here. So paying, yep, counting this. So now we're going to move over to actually looking at DNS records. So we're looking at some A records, some quad A, such. You know, there's a tool for this, and it is called NSLookup. So a query internet name servers interactively. That's effectively what it is. So if I were to go ahead and maybe do something like, let's just kind of do NSLookup, and pay attention when I do this, google.com. Question, if TTL today is 128, then tomorrow TTL should start with 128. Correct. Yes, it should. If it's 127, it can simply mean a router or switch along the way. Correct. So you could just have an additional node, something change in your network, or, as Hades is worried about, you might have a man-in-the-middle attack going on. That's also a possibility. So, if we do just like a general NSLookup on www.google.com, you can see that we actually get pointed to some IP addresses over here. Do we have a way to know if someone has pinged our device? Yes. When we get to Wireshark, you're actually going to be able to observe the echo request and echo reply action. So you can monitor network traffic for these two. These are the messages that you want to monitor. Echo reply and echo request. For you, Joe. Yep. So that's like one general way we can start using NSLookup for like a general output and a dump. J-Ray, man in the middle using a PC should ideally not reduce TTL though, right? It entirely depends. It entirely depends. If we're just dealing with MAC address routing, and maybe it's not actually like reducing and sending like an echo reply. Maybe it's just proxying and letting the connection go through it. It may not actually reduce TTL. Maybe it's acting like as like a relay and kind of like rebounding the network request. That's possible, because if the man in the middle attacker, and let's think about this. We have two steps that happen here. Now imagine that someone was sitting in the middle of that. Windows knows whether it should or should not reduce the TTL. Same with your router. It knows. But a man-in-the-middle attacker can go and craft. It can set up like a response that if I receive an echo request from Linux, and it says that it's supposed to be going to Windows, Well, I'm just not going to reduce the TTL. I'm just going to change the packet and pretend it never happened. You have to keep in mind, effectively all of this data that goes along the OSI model can be interpreted. It can be read and it can be changed and it can be crafted. So not always. No, Jay, not always. So NSLookup is a tool to be able to look up DNS records. Now, the more preferable way to do this is actually go and specify the type of records that you're looking for. So we can use TAC type. Yeah, you're welcome, Jay, for sure. You can use TAC type. We can specify. So if we wanted like just the A record, let's just say for like google.com. Here, we're going to see we have a very similar type of answer. We have a bunch of A records that are appearing to us. We could do maybe like the quad A. Or we just get the IPv6. Now we can get the name servers. Remember we talked about the DNS name servers. Name servers they're effectively like the authoritative servers towards the end of that DNS resolution request. So we could continue to find out who or which servers are supporting which domain. So now that we have the name servers in place, we could do something like NSLookup, and we can go and look up maybe like google.com again, but now we can specify the name server that we want to interact with. So maybe let's choose like nameserver1.google.com. And now we actually get a bit of a different output. You see over here, it says that these are non-authoritative answers because there isn't an authoritative server to confirm for us at this time that these are actually the DNS servers for google.com. But if I put it in here and I specify to look up google.com and I say go and speak to that name server, that output's gone. Because I'm saying that this is the authoritative server for us to interact with. So NSLookup won't assume that information unless you put it in. So what is effectively the NSLookup for? Think back to when we covered DNS. DNS provides domain name resolution and additional text-based information for the administrative side of the domain, like the security settings, who owns it, registration dates, expiration. That's what it's for. So if we can't ping a host, we can always try to perform a DNS resolution on the domain name to see if we can get the IP address from it that way. That's where you're going to use a DNS lookup like this. And last but not least, and this is the same way, sorry, by the way, this you can also do inside of Windows as well too. I can try to ping Google, not necessarily going to work. That's kind of what I did before, but let's do like a TAC type. It's a So let's go and try and actually see if we can ping Google. Let's see if the network settings are permitting this and if Google is accepting it. So, same thing as earlier. Then hit Control-C to break out of it. Nothing. And if I were to go to ping... let's go to just google.com. See what happened there? I pinged google.com, and it grabbed one of the IP addresses from the A records that were returned to me. So, in this case, we can't ping Google. Network's not permitting it, or Google's not responding. And it's not responding with an echo reply. But see what happened here, right? I performed DNS resolution lookups for the A records of google.com. I got the IP address from one of them, and then I could ping it that way. And when I pinged google.com, a DNS lookup happened when I did that, and this matches up with one of those A records. Yeah, Google's sleeping. They don't want to be bothered. It'd be pretty annoying. There's billions of people, right? I don't think they want to be pinged all the time. Yeah. Cool. Cool. So that's effectively working with records, and I think now you can get a better idea. So imagine when we went back to the DNS lecture, and we were talking about this like resolution process. It happens very, very quickly, like super, super quickly. If I just do a request like this, you can see that the server is me, right? 127.0.0, like this is us in this case. We're referring to ourselves as the DNS server on port 53. And the A records that I mentioned are these. Like these are the A records that we were trying to obtain when we did that DNS lookup request. Okay, saying would the load balancers I swear like I mute things all the time, but I still can hear pop-ups. 1 second. So KSJ, would the load balancers handle requests and tell if there's something the servers need to be communicated about? Yes. So that's yeah, I know, right? It's always going to find a way to make notifications. So yeah, good question with their KS. Would the load balancers handle requests and tell if there's something servers need to be communicated about? I would say there's a good chance. I would say there's a good chance that just because Google is not replying doesn't mean that Google didn't receive it. There's probably a proxy or a server or something in the front that is monitoring all the types of requests that are coming in and logging it. Now, I don't know if they're going to be logging all the ping activity every single day. Maybe they are, but there's a good chance, just so that they can generally see like what is the activity coming. Maybe they get like 5 billion pings as like that's their normal. Now, if they were good IT and good security and they're monitoring this, they're probably then just looking out for anomalies of like maybe one day there's 100 billion pings. That's probably what they're going to be notifying and alerting themselves on. Last but not least, we have the dig command, and a dig command is specific over to Linux, and it's effectively just, I mean, some people like dig over NSLookup. I'll kind of show you why. Let's go to google.com. If I do dig google.com versus NS, with my iPad screen, if I did this compared to NSLookup google.com, This is a really different output. It's like effectively just tossing me some name server addresses for me to look at, kind of go from there. Some IPv4, some IPv6. Cool. Like we don't really have anything specified. We have to go and look into individual records to make sure that we're getting what we want. Whereas dig right away is telling us, like, here are the A records that you want. So we know that, we know that these are the A records for sure. We also get just like a little bit of information about like the query time. We don't get that inside of NSLookup. So this actually took 7 milliseconds in the message size, the server, and when this activity actually happened. We also see our query. So this is our DNS query in action. And we also see the UDP protocol pushing this message out. So dig is a little bit more in depth. And if we were to go inside and do like dig google.com and go to like A, just for the A records, we can do that. We can also do like text records. So this is effectively, I don't think we really got any text records over there now. So let's go ahead and do something like NS, so just for the actual name servers. So here you go. Here's the proper name servers this time. NS1, google.com, and such. And we could also specify them and do something like, actually, let's see if we can do this name server to google.com for the text records. There you go. So let's kind of show how that worked. So when I just try to query text records, like through a normal DNS request, without specifying the name server, notice that I didn't actually get any information. So if I did a DNS request for the actual name servers for google.com, or at least from what we can determine that are publicly available, hit that again. And now we see ns1.google.com. And now if I specify like dig at ns1.google.com to the domain google.com for text records, now you actually see some of these text records in action. We see some SPF. So this is what we're going to get into later, but like records that we can trust Google. There's some DocuSign stuff, some Facebook domain verification, some Cisco information. Pretty cool. So these are what text records would more so look like I mentioned, like things that you can validate or get like a signature or a timestamp. That's what text records are. So pretty cool. That's effectively how we would work with DNS queries towards a domain. So you got two tools in your tool belt for testing connectivity. Ping and either NSLookup or dig, depending on your preference. This way we can verify echo requests, echo replies to determine if the host is up and live. And if not, we can also do some DNS requests to see if we can resolve the IP address. Two ways, two very important ways. So I would expect you as students, as you kind of move up in the field and your studies, if you can't connect to a host, I would expect you to have already tried to ping it and already tried to perform a DNS resolution on it. At a minimum. That's what I would expect to do. And if you were in the job, they would expect the same thing too. If you were in IT and you're like, well, I can't connect to this other workstation, it's the expectation that you've already performed diagnostics and connectivity to determine why you can't connect to that workstation. So the question at that point would be more not, hey, I can't, like, do you know why I can't connect this workstation? The question would be more like, I can't ping or resolve the domain IP address. Can you connect to that workstation? You see, that's a very different type of question. That demonstrates your ability and your understanding right away. Cool. All right. I need more coffee. That's what I need. I thought 1 cup was enough this morning. It is not. So I'm going to take a little bit of a break here. I think that's good. So we just completed the first lab. Is done. We've done lab pinging and DNS lookups. We're going to move over to curling the API and wgetting the file. Break time. Go fill up your coffees. You'll see an ad. Your sub, you won't see an ad. 80s. Yeah, you know what? I do need a coffee emote. I agree. Good call, man. Just put a little message over here. Back. Coffee. Coffee, coffee, coffee. Yeah, I need to get an emote here for coffee. Let's throw that. Let's pin that thing up. And we're gonna, I don't know, like 10 minutes tops. Put that over there in the time. So you should see a little timer in the chat now. Yep, at the top. Kind of right over there. Cool, cool. All right, let's go take a break. We'll be right back. Let's do this. Go fuel ourselves up. And I'm back. How's it going? I'm gonna open up the stream over here. Another tab to test something. Apologize for a little blast of noise. Alright. Hope everyone's got their coffee. Duke, good to have you back. All good. Yeah, all good if you missed yesterday. It's all good. I appreciate you being here today. No, not yet, CI. Gonna do that after today. Kind of see how everyone's feeling. What do they prefer time-wise? Senpai, Kuma, welcome back. Morning. Cool. All right. Let's see where we are at now. We're going to be moving on now to curl the API and wget the file. Okay. We just did some connectivity with ping and DNS. Let's take a look and figure out how we can utilize two more really good commands. One, perform a little bit of connectivity testing. But also, Eric, wheat thins and peanut butter. That actually sounds like a pretty good kind of peanut butter, though. Crunchy or smooth? That's the real question. That's actually the most important question of the stream today, I think. Just gonna say that. There's only one right answer. Smooth. Ah. Yeah, that's fair. Yeah, crunchy for sandwich, always. And smooth otherwise. Otherwise it gets too, like... It can be okay, like a crunchy peanut butter spread on a cracker, but then it becomes maybe too much crunch. You gotta balance out the crunch versus the smoothness of the surface of whatever you're eating peanut butter on. See, a sandwich is soft, so you want crunchiness. Crackers are hard, so you want smooth. Like I said, most important question of the stream. Okay. Curl. Curl. So, what is curl? It is also... Okay. So it is a physical activity in the gym, but it's also the ability to interact with a URL, which we've covered already, talking about like the fully qualified domain name and such. So what we're trying to effectively do is, yeah, you know what? Let me just actually demonstrate it. Go to curl, and we're going to go to google.com. Watch what happens. Whole whack of stuff. Up to you, CI. I don't want you to feel so rigid. I want you to be able to, if you want a new terminal, if you don't want one, I want you to feel like you can make that decision. Either one is fine. So we can do a curl, and if we take a good look at all this, this is effectively Google. This is google.com on the terminal. And what you're seeing here actually is HTML. Karina, it's all good you're late. Yeah, a few challenges came up this morning. It's okay. Sundays can be challenging. Good to have you back. So what can we see here, right? We can see news.google.com. We can see, what is this? Maybe some type of like image. It's referencing YouTube. So what we've effectively done is we did this. Instead of going to the browser, we just went here. We dumped this page down to the command line. The curl was just simply curl www.google.com. That's effectively it. And everything happened in the background. There was a DNS request. We made a TCP connection, if necessary. We performed a GET request. We've talked a little bit about that. We performed like an HTTP GET request. That's effectively what happened, which kind of just looks like something like this. GET HTTP 1, and then kind of looks like you're gonna see like a bunch of headers, and it's gonna say like something like host google.com. It's also gonna say something like user agent, which we're all gonna look at later, but that's effectively what we've done. We've performed an HTTP GET request on the command line. The same thing that your browser does. Here, the difference is your browser renders all of this HTML code. So I'll be a little bit slower. If I right click anywhere here on this browser and I go to inspect, what you're seeing here, all of this is what we just brought down to the command line. All of this HTML code that the browser looks at, renders for you. It actually creates a visualization from this code for you to look at. That's pretty cool. Curl is not necessarily to look up websites. No. Curl is a command line tool that allows us to interact with URLs to be able to perform, for all intents and purposes, browser-like activity, but on the command line itself. So let's actually take a look at that a little bit further. We go to applications, and I'm going to go to the internet. Let's open up Firefox. You can see some of this in action. SCI. And it's, when I say URLs, you have to remember, right? A URL includes the domain name. So the domain name has to resolve to an IP. Curl is effectively, it's the command line version of interacting with URLs or domains with like common protocols like HTTP, HTTPS, FTP. Effectively anything that I can put inside of the browser search bar. So let's start a new session. Anything here that I'm typing, give that a second to load. Anything that I type here, I can effectively do on the command line as well. And curl allows us to do that. Same with wget to some extent. An easier way maybe to think about it is that it's meant to transfer data to and from a server via the command line. And remember that servers are going to be accessible through MAC addresses and IP addresses, or their domain name. That's it. So curl is going to allow us to interact with the IP and the domain out of that stack. WDG, thanks for the follow. So let's take a little peek behind the curtain, kind of see how this stuff is going to work. And what we're going to do here is we're actually going to interact with something called an API, because I've demonstrated for you a little bit right now. Like if we were to perform an HTTP request here via curl, I'm going to hit enter, and I'm actually going to pipe this into less. Okay. So if I am inside this reader now, you can actually see doc type HTML. Like here is the HTML code. So you can do this and kind of like peruse through it, your liking. It looks like 341 kilobytes were... So google.com, like their homepage, is 341 kilobytes. That's what we actually brought down to the command line. Since COVID, all the bots crawl and curl the web page. See yeah, that's what happened like with the GPUs. Everybody was, especially like when Ethereum was a big thing to mine, everyone was buying GPUs and bots crawling everywhere and all that stuff. Good stuff. So let's go back to the browser, and what I want to do is demonstrate some functionality with curl so you get a better sense of how it can actually work with. I want to go to, I think it's called like IPFI. A simple public IP address API. Yeah, PS5 concert tickets happening everywhere now. So IPFI, IPFI. I don't know what sounds better of the two. Maybe IPFI. IPFI. I don't know where they're going with the pronunciation of that. So, anyways, what this website does is it's a server that provides the service of giving you your public IP address that is available or is part of your ISP. So remember we talked about LANs and private IP addresses like class A, B, and C networks at home, like the 192.168.2.1 IP address that you might see at home. Cool. Well, when your connection goes outbound, right, when it passes through the router, it goes through the demarcation point, and your request is now living on the internet trying to find where it needs to go. That request, after it leaves your network, the source IP on the connection is actually your public IP address. And we're going to talk about port and network address translation that supports that a little bit later. So IPFI is giving us our IP address on the command line for us to work with. That's pretty cool. That's really handy, right? If we don't have the information readily available. So it's telling us to get our IP4 address. Let's zoom in a little bit here. And it's saying if we run this command, curl https api.ipfi.org, format equals JSON, provide the IP and the value. So let's dial quickly back to Windows registry days. Remember when we were messing around with the Windows registry and we're talking about hives and key value pairs? Here's that notation again. Here's the key, here's the value. And this is actually JavaScript object notation. We talked a little bit about in PowerShell how Windows is trying to create objects, and objects have like these properties, and properties are made out of key and value pairs that we can reference for what we need. So if I were to say like object.ip, say I needed to ping object.ip. So if I were to go to like ping object.ip, I could have my terminal immediately reference the value of 3.225.222.31. I don't have to memorize it. I don't have to retain it anywhere. It's just inside of a record, and I could reference it this way. So that's the power of objects, and we're going to get much more into that a little bit later to try to give you a bit of scope what's actually happening there. So let's actually run this command, kind of see what's going on. So I would do curl HTTPS, and we're going to go API, PFI.org. Actually, no, that wasn't it. Hold on a second here. It's this. Let's do this. I'm just actually going to copy it. Pretty cool. So this is actually the public IP address of this network. So if I go inside of my preview range here, see how I have Linux and Windows? It says, here's my private IP address. This is a class A, Linux 10.21.67. Excuse me. But when the request goes outbound and it passes through the router and passes that demarcation point and now lives on the internet trying to route where it's supposed to go, the source IP address will be observed as 3.225.222.31, which is a public IP address. Remember that private IP addresses are not routable through the internet. This is actually our public IP address. This is the IP address that you try to hide when you go through a VPN and you try to say I'm coming from a different source IP destination. Kind of like when some of you hook up a VPN to go watch Netflix in another country. Maybe you want to watch the latest anime. Maybe you want to do that. Well, you're going to go hook up a VPN and you're going to say that, hey, actually my public IP is from a Japanese ISP. That's what's happening. And that's why you can connect to other sources outside of your country with a VPN. Pretty cool. So that's kind of the power of being able to run like a command like curl on the command line, is to be able to interact with servers. And this way we can reference their domain name, and we're using the HTTPS protocol. And we're actually hitting this thing called an API. So an API, actually before I hop into that, is anyone not understanding why I ran this command and it provided this? Does anyone not understand? Yeah, I'll repeat again. Does anyone not understand why when I ran curl https api.ipfi.org with format of JSON, why it returned this value? Okay, I guess we'll start back over. Yeah, we'll go with Eric. So curl is not used to find IP addresses, no. Curl is used to transfer data back and forth from a client and a server using common network protocols like HTTP, HTTPS, FTP, and what have you, SMB and all that stuff. It is a command line way of interacting with a website instead of the browser, as a simpler way to think about it. That's what curl does. So when I run curl against this request, right, I'm putting in, see, HTTPS protocol. That means this is a secure HTTP connection. And I have api.ipfi.org. Remember the whole notion of fully qualified domain names. You remember that? Think about that for a moment. I'll kind of show this a little bit slower then. Curl HTTPS. I'm just going to go actually to IPFI.org. Okay. Pipe that inside of less so you can see what's actually happening. If I do just this, notice how I'm going to get an HTML output. So I'm effectively like, it's like me going to the browser. I'm going to strip off the www now for just a quick second. That's going to actually force me. So that's effectively like me trying to do this. That's what I'm doing with the command line. Yeah, I'll do that in a second, Hades. And we'll do this, but now imagine I went to www.ipfi.org. Now I actually have the website. So curl has to be quite specific. The browser will fix those things for you. Now, what this is saying right here is this, right? Like, IPFI API is a simple public IP address. Where is that on the web page over here? No, it's not there. Let's do... Okay, here we go. Header 3. Want to get started right away? Don't wait. Run one of the code samples below in your terminal. Want to get started right away? Don't wait. Run one of the code samples below in your terminal. So what curl is allowing us to do is effectively navigate and browse and interact with a website via the command line. And if I go and I try to inspect this page, you're going to see that the browser, all what it's doing is just taking that code and creating a visual for you. It's creating graphics. Here is the code. This is what is actually happening under the hood. On the bottom left, if I do, I'm going to right click this and go to expand all. Here it is. I'm going to search and say, want to get, find that. You know what? I'm just going to go and click on this little inspector tool, and actually I can highlight that. Here you go, on the bottom left. Maybe I can zoom in a little bit. Want to get started right away? Header 3. Let's do that one more time. IPFI.org. Pipe that into less. I'm going to go search for it now on the command line. Want to get started right away? Don't wait. Run on the code samples, you see? Now, I'm piping into less so I can search through it. Otherwise, if I just did a curl request, it makes a single request. And it's just gonna dump it to the command line. And then it's done. So curl is, like I said, it's for transferring data to and from client-server connection. So I'm creating an HTTP request and I'm dumping it to my terminal. But if I wanted to pipe it into less, I could to search through it. But that's all I'm doing. Curl is allowing me to effectively browse websites on the command line. Super cool, right, Karina? Yeah. Ejuke. Hey, welcome. First time. I can only ask if you would be able to help me if you know English-speaking stores you can buy cheap soft packages. I don't know. That's a pretty loaded question. I would say look for sales around Black Friday coming up. Ejuke. That would be my best answer for you. Best Buy's probably got a sale for you. Wait for then. Coming up. So, on that notion, let's go back now. Let's kind of go up a command. There's a difference in what I've done here, and I'm going to actually show that to you. If I went to api.ipfi.org, and I'm going to pipe that inside a less, you can see nothing actually happens. Let's go to the browser. So, in this case, I'm actually surprised why it didn't actually dump the IP. Or did it? I just wasn't paying attention. I think it did, didn't it? Oh yeah, it did. Okay, yeah. I just didn't see that on the bottom left. Yeah, cool. Okay. Yeah, so if I just went to the API, it's just going to tell me what my public IP address is, just like this. And remember, IPFI, excuse me, let's go back to the main page. Ever needed to get your public IP address programmatically, so just like automatic or used within scripts and code? Maybe you're provisioning new cloud servers and you need to know your IP address. Maybe you're behind a corporate firewall. Maybe you want to go watch Japanese anime latest episodes. Whatever you want to do. Well, maybe you want to know your public IP address so you could see if it's actually valid. And maybe you want to hop in through a VPN or change things around. IPFI is a server that sits outside of your network. It sits online on the internet. And all what it does is it just waits for a request coming from your network, and it says, hey, well, what's your source IP? Like, what does your ISP tell me what your IP address is? And then it just sends it back to you. That's all it's really doing. And this is just one website. This is one service that does this. And this is all accomplished through something called an API. And an API stands for Application Programming Interface, I think, yeah. It's effectively a way to allow a server, let's talk about like a server API for now, for all intents and purposes. If we change the subdomain of IPFI, okay? Yeah, see, I'm just piping it into less to make it easier for me to read and demonstrate on screen. Otherwise, it's just going to keep dumping it to the terminal. Less is just a reader to read text and read standard out. So, if and this is IPFI's structure. Some websites would have like some website.com/API v2/IP. And then you would have to put in like format, like something like that. Every website's going to differ a little bit. It depends on how the developer set it up. In this case, IPFI is saying if you make a request with the subdomain of API, then the server will accept that request and the server is going to run code. And it's open to the public. Some of them have passwords, some of them have keys, but it's available to the public. And it's going to run some code. And if you tell it the format of JSON, more specifically, or if you don't give it a format, and you can choose the format that you like, all what it's doing is the server is going to look at your public ISP source IP address and then send it back to you. That's all what's happening. And this is the beauty of APIs. You can create a server online that does functionality for the public or for a client, paid. And depending on how you structure the fully qualified domain name with file paths, it'll do different things. So this is just a service that someone created. Pretty cool. Now, APIs allow us to adjust or request things from software or websites. And it's effectively... I'm trying to think of an easier way to relate it to this. One second. It allows an HTTP request, in this case, which is a common type of request, like the World Wide Web works through HTTP requests, as you can see. It allows us to use an HTTP type of request, but then retrieve other protocol types of data. In this case, JSON, which is more of a rule or more of like a language or more of a format. Now, notice, like, I can't go and do something like curl JSON API.ipfi.org. Like, that's not going to work. It's not supported. But I can curl and make an HTTPS request, which is normal on the World Wide Web, ipfi.org, and then what was the actual, how did it actually structure? Let me take a look. Format equals JSON. Okay. Format equals JSON. And then I saw in the chat as well too, I think, who said it? It was further up, I think it was Kim. XML. Or no format. So that's how powerful APIs are. Like, I'm just using a normal standard type of connection, and I can retrieve formatted data from the server for my needs. And this happens through an API. An API it's like putting a tag in front of the request and saying, hey, wait a minute, this is an API request. I need the server to do something now. I need the server to run code or execute a function. And this happens with software. If you make an API request to local software running, it can also do that. And the major benefit of this is that it allows different protocols, different software, and different technology and communications to speak to one another if they weren't designed to. As you can see, I cannot make a JSON request when I try to do that. Here, if I try to do like, something's really borked the terminal. If I tried to make a JSON type of request, it's not going to work. But maybe JSON is the format of data that I need, or XML, or CSV, or .doc, or PowerPoint, or like all those extensions. Maybe I need something in that format. Imagine the hell it would be for developers to create formatted types of data in every single possible way for you on every single type of domain and get that already. Well, you don't need to do that if we just have the ability to handle a temporary exchange, and that's what the API is doing. So I think I'll pause there and I'll also do a little bit of visualization, kind of show how that's looking. Well, and cool, wow, we got a couple followers over there. Ningu, Seko, and MT Cianuro. Thank you, 3, for the follows. Thanks for being here. Okay, so let me actually go and kind of walk through this. It's actually looking like. That's typically like the normal process of your client connecting to a website. You make an HTTP request, server sends HTML code back. That's sort of like the default thing that happens. But like I said, you can see a problem there, because if I wanted, or if I needed data formatted in a different way or different protocol, this won't work. If I were a client and if I said that I want to make a JSON request for you, and JSON, like we talked a little bit about, something like JSON would effectively be like IP value. Like it's effectively a key value type of formatted data, kind of like the registry hive was in Windows. So if I wanted to get JSON types of data from the server for code, other types of functionality, and I tried to request that from the server, well, the server is only going to be understanding common protocols like HTTP, HTTPS, FTP, these things that we've sort of talked about for now. So the server is actually going to be like, no, I don't support that. And it would create a lot of work for developers to have to create that type of supportive functionality. So what we've come up with is effectively this API. It's like I said, application programming interface. This is a concept. More than anything, it is a concept that is then realized by the execution of your computer running code to perform functions that are otherwise not intended or intentional by design. So what I'll do is I'll go inside here and kind of demonstrate that, what actually happens in this case with an API. Client is going to do this again. And I'm going to send an HTTP request with an additional request for JSON data. What happens here, server now, server is going to, first, it's not actually going to send any type of communication back to you. It's going to go internally. And it is going to try and run some code. The code is effectively like, hey, need JSON. And then from here, this is actually the API in action at the server level. It's going to then package up an HTTP response. With packaged JSON inside. Your client then receives exactly what it asked for. That's what's actually happening. The API is just code. It's just a script running inside and on the server. J-Man, thanks for the follow as well too. And yeah, so okay, I was saying, so we're actually going through the SOC 100-1 course together. We might do some additional streams for like Advent of Code and stuff though. But this is a SOC 100 course stream. Did that make more sense, everyone? understanding what this API is doing. Cool. Good. Excellent. Perfect. Good, 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 good. That's what's happening underneath the hood. So, let's have some fun. Follow-up, does one always have to redirect the curl response to grep with it? No. No, no, no. You can do whatever you want with it at that point. The server is just programmed to give you a response to your preferred output, if it's able to, based on its supporting functionality. Like this, it gives you JSON or XML or whatever else you'd prefer. The rest is up to you. You can grep, awk, cut, sed, whatever you like at that point. That's up to you. The point is, you now have data that you need to work with in a certain format that you need. So let's go have some fun. Let's look at another type of service, and it's actually called PokeAPI. I think we need to find out some information on Pikachu. This is a really important stream today, talking about peanut butter preferences and Pikachu. Okay. So here is a server called PokeAPI.co, and this is a server that someone built that just provides you all the information that you need. It is your Pokédex. If you need information on a Pokemon, that's what this server will provide you. So let's go and find out exactly some information that we need to know about Pikachu. So in this case, you can see that they tell you how to work with it, and all the servers will do this. There's an API, and they tell you what you need to do, like how you need to format the URL, how you need to format the path, or there's rules. They tell you how to do it because they've designed their software for a certain way. So in this case, it's saying a couple different options here. You can look up Pokemon like Ditto, but let's take a look and see what it looks like for Pikachu. I choose you, that's right. So I'm going to submit this just to actually see what it looks like. And this is what it's saying I should receive. And here's that JSON format. And you can see why JSON's so like nice in this case, because it's all nicely structured. Name, here's like the URL, name, lightning rod. So Pikachu has the ability called lightning rod. It can also do some cries, like it can scream. And it's various different forms. So let's go and see what that looks like on the command line. If I were to do like curl, HTTPS, and notice the difference, right? PokeAPI.co, API, what was it? API v2. See, like I said, there's always like a version 1, version 2, and that's just naming conventions. You'll see those. Oh, jeez. Thanks for letting me know, Cap. So if I were to go to pokeapi.co/API v2, and if I were to go, and what is it over here? Pokemon/Pikachu. Okay. Actually, scroll up. /Pokemon Pikachu, and I'm gonna hit enter. Now that's a whole whack of information, right? That is what we saw on the web page. But now we can bring it down to the command line. Maybe we want to make a script on something. So we can pull this information down with curl, or we can pull it down from a browser, but curl allows it to bring it to the command line for like scripts and code and execution. Now, I think we have... Yeah, we have a tool inside here built for you, and this is called like JSON pretty print, I'm pretty sure. Yeah, pretty sure it's JSON pretty print. This is going to allow us to bring that information down on the command line, but clean it up. So we can use tools like this, like get all that raw data, and we don't need a browser anymore. We can just go straight to JSON pretty print. And you see how like it's all like nicely formatted now. Let's put that inside of less so we can actually see it and kind of scroll through. Here you go. So now this is data that we can use bash for scripts, and we can make some pretty cool stuff. Like maybe we want to make a bash script that gives us like the latest updates on Pikachu's activity every day based on what the server is tracking. Maybe we want to make a bash script that connects to a weather service that has a weather API, and we could run it and it'll let us know what the weather is outside. And guess what? That's what developers are doing. When you go and you see, if you're like a Mac user and there's like a weather app, well, it's just a script that's running that it's just telling you what like the latest weather is. Or if you look on your phone, over here and it has like a weather app, it's just a piece of code that is running and it's connecting to another server, and it's getting what the weather is, and then it just makes it look nice on your phone for you. But you could do that. You could do that now. Like you could make a bash script and interact with the PokeAPI or like weather API.app, and now you can actually build some cool things. But that's the power of being able to work with these network protocols on the command line. And additionally, this is why APIs are so valuable, is because we can get very complex formatted data that we need for advanced use cases on the command line and other sources by using API requests with common network protocols that are very heavily supported. Does that make sense? Yeah, very cool. I would recommend for you to all go and do that. Go do a Google search and be like, free API for testing. Weather. And, you know, just be careful, like whatever things you're interacting with. But I don't know, open Medio or Mateo features free weather API. Here you go. Cool. That JSON, I think it was, right? Yeah, nice. Put that inside of less. Here you go. Go make a bash script now. Go make a little tool that tells you like what the weather is. Here you go. Here's the current interval, seconds, elevation, relative humidity, history. This is what's so cool about being able to work with APIs now, is you're not limited. Like you don't have to go and build like a whole whack of software yourself. People are doing it for you. This is how developers contribute with one another. They have these services where they can provide API data for you to work with. And like that's what they do. This developer is like, okay, I'm gonna go track like the weather history from this, from whatever service it uses. And whoever needs it, just make a request to my server. And then maybe they'll ask for like a support of like coffee or something, you know, like go give them like $5 here and there kind of thing. Up to you as well. But typically they're always like this, like open source, free. And then of course there's paid ones you paid a lot of money for. Like when we look at like cyber threat intelligence later, you have to pay a lot of money for this type of API data that is curated by like the best of the best in the field. So you get free ones, you get paid ones, but really like you're not limited anymore. you know now how to make a curl request to get API data for you to work with scripting and code. And that is friggin' cool. At least I think so. I think so. Cool. What do we got next? What are we doing next? wget, right? Yeah, that's right, Kim. You could go and hook up ChatGPT's API and speak with it directly now. And then you could sell it as a service. That's what people are doing. They've created like ChatGPT APIs that looks like you're just like using their app, but it's really like pulling ChatGPT info. Super cool. Sky's the limit now. Literally. Lobe chat. Yeah. So, I think the last thing, I want to show real quick was just the wget, and we'll take another break. Wget is another type of command. And it's pretty cool. Like, kind of similar. Kind of similar to HTTP. Sorry, kind of similar to curl. That's what I'm trying to say. Kind of similar to curl, but it's meant for downloading. Hence this, a non-interactive network downloader. So remember what I said in the beginning of the SOC 100. Eventually, you can just get to everything on the command line. You don't need the browser for mostly anything, unless you just want to like, consume media. But at a data level, you can hop on the command line for everything. So wget is a nice way to download files using common protocols like HTTP, HTTPS, FTP, all that stuff. That's what that's doing over there. Zool, thanks for the follow. So that's what wget is. It's very, very, very similar. Let's go and see if we can download something so you can see what it'll look like. I'm gonna go back to the website here, and I don't know, I'm gonna go and right-click this file. And I want to say open image in new tab. I want to get the actual like URL for this. Clouds. No, I didn't want that. I wanted the logo. You know, let's go to example.com. It doesn't have a logo. I swore it did. Okay, let's just go back to something else. Sure. Let's go here. Now, I could go, if I'm inside the browser, I could do like right-click and save as and all that stuff like you might be used to, like downloading files that way. But remember, we're in the command line now, and we have, what do we have here? We have a protocol of HTTPS. We have the domain openmedio.com, and we have a path on the server saying images and convectiveclouds.webp is available for us. So let's go and copy that. And I can go run something like wget this file, like that's the location of the file on the server. And I'm going to say tac o for out. So where do I want this to go? And I'm just going to call this like clouds.png. And watch what happen. So it's resolving the address. It found the IP address, did a little DNS lookup for us, connects to it, 443 is the protocol for HTTPS. You can see the HTTPS connection happen here. Now that it's established, we're actually sending an HTTP GET request. Waiting a response. We got a response of 200 OK. We're now saving that image of what we just specified in the full URL. We can see the process of it downloading. It took 0.007 seconds. And the final file is 2.87 megabytes in size of clouds.png. The cool thing is, wget actually records a... I think it does, doesn't it? I thought it actually records a log by default, right? It's not there, so I swore it actually writes the same directory, but I guess not. Maybe there's a setting that I can't really remember. But either way, so now I have clouds.png. Here it is, like it's on the disk. So if we went inside and we're inside of our home directory, I'll show you where it kind of looks like it lives. Clouds.png. So it's actually here inside of our home directory. I was worried about that because it's like a WebP file. Okay, 1 second here. I'll get a better... PokeAPI? Oh, that's a lot of ads. Let's close that. Unscrupulous, thanks for the follow as well. Okay, this might be an image. Open image in new tab. Yes, here we go. PNG. Okay, so this is actually an image file. Just for demonstration's sake. Go ahead and do this again. We are going to go and do... we're going to run another wget. So wget, tac o, let's call this like EFI logo.png, put in the URL, hit enter, cool. Run an ls, and surely, here we go, IPFile logo.png. Let's take a look inside of our file browser. Go to home, IPFile logo.png. There it is. Download whatever you want now, as long as you have the IP address. Pretty cool. Pretty cool. Make sense? You could, Steven, if you'd like. I'm not specifying any path because I'm just putting it to my current directory. But yeah, you could. We could also go, we could, geez, there's make directory, Google. CD, Google. Okay, so nothing inside here. And if I were to go to wget tac r, I'm pretty sure mirrors, like it goes through and downloads the whole directory and everything for us. https.com. See if that's going to work. Probably should have just done that on a smaller website. Okay, so we just downloaded Google. 11 megabytes. We now have Google. Power of the sun in the palm of our hand. Go to Google, google.com. Let that load. Look at that. And edu, yeah. You can use TACO to specify the download location and what you want to name it as, or you can just download what it is. So take a look. We've now effectively downloaded all of the supporting things of Google. Like here's the index.html file. Let's actually open that up with let's do text editor. Here you go. Here's all that HTML code. So if you wanted to download a website locally and then do some analysis and like strip everything down, awesome. Here you go. Get everything you need. Same thing. So robots.txt is a file that tells crawlers not like what not to download. So that's why you can see like a bunch of things might have gotten like see like allow search about allow this, but it's saying disallow groups. And I didn't download the groups folder as a result. So like their websites have these robots.txt files that'll tell scanners what they can and cannot download. And CI, this is wget. Wget is the downloader. Pretty cool. Good spot to stop. Taking a little break. A lot to cover. A lot to cover. Oh no, that was one lab. It was two labs. See if we can make it that map today. Cool, cool. Yeah, Karina, real quick. Take a look at that. So I went to the ipfi.org website. Let's go and actually look together how I got the full address for just that file. With your cursor on the screen, you can right-click anything on a browser and you can go to inspect and find the exact location. Or if you right-click on an image, you're going to have the option of open image in new tab. So if I click on open image in new tab, and I go to the top, you'll see logo is now available for us as just the location of where the logo is on the server. So I grabbed this URL and I copied that. Cool. Yeah. Nice. Okay. Take a little fiber as well. Trying to keep a cadence of like 1 hour break, 1 hour break, 1 hour break kind of thing so we can digest. Cool. Let's take a little bit of a breather over here. We've now learned how to... At this point, like, again, sky's your limit. You can curl any server you want, interact with APIs, and you're just going to get better and better with it. So there's a lot of research you can do. Curl, wget are very extensive commands. There's a lot of like tips and tricks and things you can do with them. I just showed you sort of like the tip of the iceberg. Enough that you can understand that you don't need the browser anymore. That's pretty cool. No more browser. Yes, finally. One day we will be just on the command line. All right. Yeah, super cool. Let's take a little bit of a break. I'll be back. You all too, go take a break. Go refill coffee, more tea, more water, stretch your legs. snack time. All right. Back in action. That's pretty cool, Hades, yeah. I love that. You really wanted that PS5, huh? Yeah, I agree with you, Hades. That's why I try to like pepper in little examples of what we're doing along the way. Like, hey, like you could go download the weather now as well too, and information on Pikachu. But truly, the magic really sticks when you start to think about practical application of your own preference. And you'll hear me advocate this quite a bit. And this is why home labs are so good. It's for exactly what you said. When it's relative to you, you'll like it, you'll enjoy it, it'll feel meaningful, it'll feel purposeful. And it's going to stick with you as a result. And you're going to keep on doing it, and you're going to want to learn more about it and become more proficient with it. And it's all because of relativity. And that's why home labs are so good. Is to do what you're doing. Is exactly like that. Go build a PS5 script scraping bot so you could go and secure a copy, or concert tickets. Go and do that. That's super cool. Karina, back when you used to shop a lot. There's nothing wrong with shopping. He dreamt of something like Crow let me stock websites for my size to come back and stock. Yeah, nice. It is time, Karina. You must build shop bot with Karina mode. Go and find your things. Nothing stopping you all from doing that now. Cool. All right. Let's move on a little bit more. Let's keep on pressing ahead. Next, we're going to move into SSH connections. And we'll try to maybe like lightly touch on cryptography, but not a whole lot because we have a whole section on that. SSH is effectively... It's effectively like creating a TCP connection to another host so that it remains consistent and stays consistent and connected, but encapsulated with encryption. It's creating a encrypted connection from one endpoint to another. Hades, you got Karina, you gotten smarter with age, and I mean, go live a little too. It's like save your money, but don't be extreme in either way, right? Like, I don't know. Don't be that person when you get to like 60 and you saved everything your entire life, you never did anything, and then you start to realize you're too old to even enjoy the money that you have. It's balance. I believe Mr. Miyagi said that in Karate Kid. Everything balance, Daniel-san. Everything in moderation. Okay. Let's jump back into this. We'll save the philosophy for another time. Focus on networking for now. So yes, SSH. Let's go and see how easy it is to set this up. What is SSH? So you're going to see something over here. It says Open SSH Remote Login Client. And then you're going to start wondering, well, what the hell is Open SSH? Well, we are going to cover a lot of cryptography later on, like I said. And cryptography is a mathematical algorithm that is extremely difficult to reverse. Very, very difficult. It requires a lot of computational power to reverse or crack. And therefore, we assume that no one can ever read it in today's technology. eventually they will be cracked as technology increases, right? But that is what encryption is. It is processing data through an algorithm, through math, that comes out the other end, and is very, very difficult to understand unless you knew what the math formula looked like. And the math formula is hidden. It's hidden so that no one can understand how to reverse what the output looks like. That's at a high level what encryption is doing. And SSH allows two endpoints to do that. They both have a secret formula on either end that they can process data through and then send it to one another, and then no one else can understand it. Through their own private little math formula, they are going to talk and create a shared mathematical formula that only they understand. And we're going to come back to this because it's quite complicated. And all what SSH is doing is using that connection to then create an encrypted communication channel. And SSH is for remote administration and remote access, effectively. So, ping and DNS for connectivity and debugging and utilities. Curl and wget for web and network-related data transfer with common network protocols like HTTP, not DNS, FTP, etc. And then SSH, and by extension SCP, which we're going to also look at in this lab, secure copy, is a way to encrypt remote administrative commands so that no one sees what you're doing. Because everything that I'm doing without encryption is available for anyone to read, and we'll see what that looks like a little bit later. So let's walk through and kind of determine effectively what's happening here. So inside of the lab, and if you're doing this on your home, you're going to have to just... I'm going to assume that you know how to set up these types of user administration, but we provided that for you. So the credentials are here for your local lab. You need to go inside here. Make sure I'm actually sharing this properly. Yeah, okay, cool. You do need to go inside of your lab to find these credentials, and these will be different from your home lab. So actually, I do have like a little chart inside of the YouTube video here that kind of talks about, I think at like a high level. So kind of zoom in a little bit about that. What is effectively happening here during the SSH connection is you, as the client, you basically say, hey, like, hello. And we're going to get into public key cryptography and such, but the client says, hello, I would like to create an encrypted connection with you. Can you show me your ID, and then I can trust that you are who you are. That's your certificate. The server responds back and gives you their ID with something called a public key. And a public key allows you to encrypt data, and that data after encryption is only accessible with something called a private key. But notice that they don't share the private key, only the public key. So that's kind of like the trick right there. You, as the client, then say, okay, I am going to encrypt a secret message with your public key, and therefore only you can ever decrypt it. Server says, all right, let me take a look and see what you said. Server opens up your encrypted message. They can decrypt it with their private key. That's the math here. At that point, the server says, okay, I can trust you enough, and let's now create a shared connection. Because when you actually sent that message back to the server, that message contained a one-time generated public key of its own. So you see what's happened here is you as the client have sent your public key that allows you to encrypt data, but only then you can decrypt it. So now that you and the server both have each other's public keys, you are now going to generate a shared private key that you both will exchange. And then that new shared private key is going to encrypt all data moving back and forth at that point in time. And that is called the session key. And we're going to come back to that in the cryptography and encryption module. We'll talk more about it and a little bit more in depth. But effectively, that is what's happening at this point in time. There are two keys, public and private. You never share your private key with anyone, hence the name, private. Your public key you can give to anyone. And if anyone takes your public key and locks up your data, that's fine, because then only you can read it. Again, we'll come back to this. But this is what's happening under the hood with an SSH connection. This same type of thing called a key exchange. Oh, I just saw that. First time Chato, Jing, Vikram, Bachelor's Computer Application, currently competing the Hack the Box, CPTS certification, having solver. Pretty cool. Do you think Saccharin is sufficient for entry-level roles in cybersecurity? Or double, yeah. Practical along this course should definitely have you ready. Yeah, agreed. Probably be a matter of passing the interview then. A lot of employees looking for Sec Plus minimal though. Yep. Yeah, that's good advice. I think they got you over there, Jing. That's exactly it. Yeah, you want to demonstrate two things: education and experience. And that's what they're talking about. Education, you can go take all the education you want. That's one half. And then experience is something you can do personally, like home projects, more certifications, bug bounties. You put those two together, and then you do the networking portion. Networking is like connecting to recruiters, going to meetups, putting your portfolio online. You have those three things. It's just a matter of doing more of those three things at that point. Arguably, you want to do less of education and start focusing more on experience and networking. And the more you do that, you will eventually get in front of someone. And as long as everything checks out about yourself, you'll eventually get a job. But that's it. It's just a time at that point. Time and countdown. And thanks for the follow too, Jing. Cool. Okay, so I'm not going to spend a whole lot of time on encryption at that point just for now. We will come back to it, but at a high level, that is what is happening. All right. So let's actually walk through and kind of see this process in action. In order for me to connect to another client, it's pretty simple. All I need to do is do SSH username. Actually, let me do close brackets because we've been sticking with that. Username at IP. That's effectively the convention. Excuse me. So what I need here is the username and the IP address of Windows if I want to remotely administer it. So let's go back. And inside of the course over here, we have the Windows credentials are administrator. So SSH administrator. Whoops. At Windows IP, and you can grab it from the console as well too if that's easier for you. Okay. Now here is where a lot of students have an initial trouble. I'll show you in a moment. First things first. When you connect via SSH to a new host, you are going to see some crazy output. That'll freak you out. And you've never really seen what that means before. Like all of this stuff here. When students first see this, they're like, what is this? So let's kind of talk about this because I've seen this very commonly. Students will just literally trip up over here and they don't know what to do. And they think they're going to blow up their computer. It's not going to happen. Okay. First of all, let's read this line by line. The authenticity of the host, so this is the Windows IP address, can't be established. That's good. You want to be warned that, right? And the reason why that this happens is because your computer hasn't connected to it before via SSH. And there's a file where this goes to and is saved after. Now, what this saying over here is like elliptic curve something, I don't know, I can't really remember what that fully stands for. But the fingerprint, and this is that public key effectively happening over here. This is the exchange, like, being attempted. It says it doesn't... It says, like, here's the fingerprint, so in case you've never seen it before, or maybe you want to make sure that this matches, it's saying, this is the fingerprint, this is the representation of the public key, kind of like a shortened... and this is kind of like... here. From that card I was talking about before? This card, anyway. It's a warranty for a hard drive, okay. So this card right here has a certain like code on it, if you will. And what happens, okay, is when I try to connect, the server sends this card to you. It's like this is their like their driver's license, and it has an ID on it. And it says, okay, here is the fingerprint. Like here's my driver's license. This is my driver's license ID. Here you go. So it's a representation that you could trust it. This is up to you. Now, in this case, yes, you can trust it inside of your home lab, but it's just a prompt. So I'm going to say yes. And I left it open too long. So let's do that again. And so it actually closed the SSH connection because I left it open too long while talking. So notice that it actually added this, and thanks EDU, yeah, elliptic curve digital signature algorithm. Too much to remember off the top of my head. So yes, there's that. And effectively, we have now added that fingerprint to our known trusted host. That's why when I try to connect again, it didn't prompt me and tell me this, because I've said, okay, cool, I trust this source. But look what's happened here. I have a password, and I am going to... I don't know if you can hear that while I'm like hammering my keyboard. Nothing happens. Nothing shows. And students typically freak out. This is the first time they've seen this, and this is actually an invisible prompt. It's hidden. It's hidden so no one sees the password, because this is where you have to actually enter the password for the administrator. So I'm going to go back inside here, and I'm going to grab this password for administrator, and... like, that's it right there, just to show you. This is my copy-paste. If I paste this in, you can see it. Now, what I am going to do is go back and create another SSH connection attempt. And then I'm going to hit Control-Shift-V to paste it in. And I'm in. I have now created an encrypted connection to my Windows computer via SSH. It is that simple. Everything happens in the background for you to see. So, I think what I will do, actually, I'm going to exit this. And what is it again if you do this? TAC V? Yeah, okay, cool. Perfect. Even better. I can put on a TAC V flag to show the, like, this is to make it verbose. CI, if it's permissions denied, it's just a copy-paste issue. It's a typo or you're doing something wrong. Slow down. Okay, so SSH administrator at TAC at 10.0.19.153. If I throw a TAC V on an SSH connection, that's important to remember because this can help you debug weird things going on with SSH. You can provide more like a verbose output to see what's actually happening behind the line. In this case, you can see it is reading the current etc SSH config settings on the system. It's now trying to make a connection to the Windows computer on port 22, which is the SSH port by default. So our SSH configuration settings are located on our system, like our preferences. They're here. So now it's trying to identify some additional cryptography because the server has responded, and it's actually looking through preferred encryption algorithms. And this is how we ended up with the elliptic curve digital signature algorithm. It's settled on this one. So now we can see there is this key exchange happening over here. Here's the message exchange and the algorithm being decided. Server to client, client to server. We're gonna walk through this again later, but I'm just kind of showing what's happening under the hood. They've done a verification check between one another. It says the host matches the key. And we're now matching this file location of home, Ubuntu, SSH, known hosts. This is the known hosts file your machine can trust from now on. It's probably going to drop the connection again, isn't it? Yeah, okay. So now it is doing the final key and encryption operations on these last steps. And it's exactly what I said. There is this public-private key exchange and certificate verification identifying that your driver's license is effectively who you say you are. And it's the exact same thing if you went to, like, the government office and you needed to provide your passport or your driver's license. Actually, that's exactly what's happening. So here, let me walk you through that. If you go to the airport to check in. Okay, so you go to the airport to check in, and there is a terminal, like when you're crossing countries, I would say, right? I don't know why, but I feel like that's a very official looking type of person with that kind of hat. All right. This is you over here with your passport. So what do? You give them your passport, right? And what they're doing on their end is they then do a lookup inside their computer systems that might have your information that is secured on a on a private registry, I should say. And your passport should check out inside here at this point in time. And if it does, you're allowed to go. Like, they're allowed to proceed. But if you're flagged for some reason, then you're denied. That is effectively what is happening at that point in time. Now, the difference here on this type of exchange is that imagine that this conductor person gave you a little code and you put a little code as well too. And you've established that your messages should always have AB with one another. And only you know that. No one else can see what's going on at this point. There's this type of initial verification check. You then share a little secret code across the kiosk. You agree on it. You both feel good. Yes, yes. Good. Okay, cool. From now on, as long as all messages contain that type of encryption, or a code, if you will, so let's just say now that this always has that. Cool. We're good. Everything's encrypted now at this point. Like you need AB to be able to read the rest of this stuff. As long as AB is in the front of all of it, good to go. High level, that's kind of what just happened right there. So, it's going to drop the connection because I waited too long. Let's go inside there. Let's put the password in. Whoops. copy this, Control-Shift-V, and I'm in. This is all now encrypted at this point in time moving forward. So now that I'm inside the Windows system, notice that I am the administrator of this local host. So I can run anything that I need to go and do as this user. If I'm an administrator, I can run something like net users, kind of do some user administration, or maybe I need to add a user in, like net user, secret user, password, I don't know, 123, add. Password does not meet password policy. Okay, cool. Try that again. Let's call this pass 123. Okay, cool. I've now created another user on the system. So secret user is now here. I could also do remote like file creation. And I can actually send files over there. So let's go and do that. So let's see where I'm at. I'm at C users administrator, right? I can run dir, see all that stuff over there. Cool. Let's exit the session now. And from Linux, let's go and say echo Gondor calls for aid. Message.txt. Cool. So now I've created this. Now I can actually copy this file over. And SCP is a command we can do just that. And what it does is it actually copies files through an SSH connection. So what's going to happen when I try to send this file over, it's going to create another SSH connection again with that key exchange, encrypt it, and then send the file over. So I believe if I do SCP administrator, or rather the file scp message.txt, and now I need to put in the username administrator at 10.0.19.153, 10.0.19.153. Now I need to go and do this type of setup here. I'm going to say C users, that's Linux. And just put that in. Now I'm going to go put the administrator password back. We can see that message.txt was actually sent over 100%, happened in a split second. Let's SSH back in. Run a dir, message.txt. Gondor calls for aid. Pretty cool. That's an SSH connection. Nice and easy for remote administration. Right? That's the purpose. That's the use case. I can go inside there and I can create an administrative session and do what I need to do. And it's all encrypted. That's all what SSH is meant to do. It's all what's really needed for. And I will log in with the same username and password for the user on that workstation. And then SCP does the same thing. It just copies files over through an SSH connection. And the format's a little wonky to kind of get used to at first. Like, let's go to SSH syntax. SCP syntax. Sure. So here we go. As long as you sort of remember generally like how it looks. Actually, don't I have it inside the course? Yeah. Hey, here you go. So SCP, like test file administrator at Windows IP. And you put it inside of the directory where you want it to go. This is the part that can kind of throw you off, and that's why I kind of like writing things in quotes at times, is be very careful with like colons and slashes once you start getting into network traffic. Just be really careful with that. Does that make sense? Is that clear? The takeaway? Okay. The takeaway being SSH creates an encrypted connection. Yeah, perfect. And SCP allows us to transfer data through that encrypted connection between two endpoints. Okay, Patricia's good. Hades is clear. Nice. Okay. It's really straightforward. It's just doing it. Like, get the reps on the keyboard. I think that'll make more sense. But again, high level for now, and then we'll get deeper into cryptography a little bit later. So we don't have to, like, derail. Cryptography, like that is a entire thing in and of its own. Yeah, I mean, there are like studied people that they spend their entire life on cryptography. Xeno, does SFTP do the same thing? Effectively, yeah. It's the same. It's kind of like SCP, but it is an SSH connection using the FTP protocol. And you're going to find this a lot. Like, SSH is wrapped around a lot of things in that regard. Because it's a really simple mechanism. Yeah. It'll kind of depend on use case. Thanks, Hades. Yeah. EDU, yeah. Remember, yes. Yes, good call out. Be really careful with like how you structure the command. It's so easy to like to overwrite things. Yeah, be super careful. Last thing I want to show was where that file was. So if I do list-tac al. Sorry, let's go back. Home directory. Notice that we actually have a hidden folder over here called .sh in our home directory now. There's the known hosts. Well, would you look at that? Here is the host connection going on. This is that stamp. It's now been added over here. There's the elliptic curve digital signature algorithm. Here is a base 64 CyberChef. Here you go. It's base 64 encoded, and we learned about base 64. Actually, I think we haven't touched a whole lot on this yet. We will a little bit later. But base 64 is a way to package up like stuff like this. Like, you see how unreadable this is, and a bunch of like this is like full of like errors, if you will. Base64 allows us to package it up in reliable data that always will look and format and be easy to interpret the same across multiple operating systems and protocols. But inside of the base64 encoded string, we can see that there's the stamp, but then there's a lot of unreadable and encrypted information here. We'll get more into that a little bit later, but this is where that file is. Now, if I were to go, and this is a common point users kind of freak out on as well too, I'm actually going to clear this file. I'm going to echo nothing into it. I'm going to overwrite it. Now, if I try to do another SSH connection over here of administrator to the Windows IP address box, it's going to prompt me again. So this is an indicator that if this file got corrupted or the IP address changed, it's going to just ask you like, hey, I can't trust this person. I don't know what this is. You need to give me the okay. That's what's happening there. Is that the known hosts file has been altered in some way, or the IP address has changed. So the trusted configuration is now no longer the same. So I can hit yes, and I can do this all over again, and I'll be fine. I'm gonna just break out of that, and notice now that it actually added it back in. Cool, cool, huh? Oh, I like when this music track picks up to this random song. I don't know what it is, but it's always good. It's like evening jazzy. Cool. Okay. Going through it. Next thing up, we've got network shares with SMB. So now we're actually going to get into the SMB protocol. This is one of the most used protocols ever. Windows loves SMB. It is a very, very easy to work with protocol. So let's take a look and see how SMB actually works. And SMB, it stands for Server Message Block. It's a network protocol and is used for sharing files, printers, and resources. And primarily in Windows domain networks. It's very, very common. SMB also provides authentication and permissions. We haven't seen that yet. We've only seen that locally, like having a username and password, but we haven't seen it from a network connection just yet. So, Joe Kid, thanks for the follow. Thanks for being here. So now we are going to jump into that. And in order to make this all work, we're actually going to have to create a network share. That's the first steps of this lab over here. Cool. Let's go ahead and do that. And remember, now that we're dealing with a session, like a connection-oriented protocol, TCP. So TCP's back. We're going to set up a TCP section. There's going to be that that handshake that occurs to establish the session. And there doesn't necessarily need to be encryption, but some of it will be readable, some of it won't. And effectively what SMB is going to do is it's going to create a session between client and the server. and the client is just going to send messages across the network. It'll be something like file open, file read, file close. Really simple stuff. And then the server will provide what the client is asking for after they've been able to establish session information and authentication information. So let's see how this actually works. All right, so first things first, what do we want to do? We want to go inside here. We want to create a folder. We want to create a share. So we're going to go inside of Windows, and we're going to go inside of the File Explorer. And I'm going to go to the root C drive, and we're going to go and create a folder over here. And I'm going to call this data. And what we're doing right now is we're creating a network share that is actually, this is something like you'll see in, if you worked at like an IT help desk position, you might be responsible for looking and investigating like network share information issues like this. And if you were a system administrator, you might be setting up a network share just like this, very similarly to what we're doing right now for an entire company. So it's not that mysterious. Karina's asking, back to SSH, I imagine SSH will time out or something like that if you give it too many incorrect passwords. Yes. Yes. That is where you can get like lockout. You can create a lockout policy. If you enter in the wrong password like 3 times, you can cut off the SSH connection for like a timeout. Yep. Good thinking. So you can set up like an SSH config. Actually, stuff aside. You know what? I'm actually just going to Vim inside of it. So we're going to go, remember in Linux, everything's a file. And just about every service has some type of like config file. And it's going to be inside of Etsy. A lot of the configurations are there. Let's go and take a look inside. So you can see this is the SSH configuration that the SSH service was referring to. Remember when I initially established the connection? I'm gonna do that one more time. Do this over here. I'm gonna put a tag V, and then I'm gonna pipe this side of less. So that's interesting. I didn't actually capture the beginning portion of it, huh? Okay, let's do that again from the top. Reading configuration data. Etsy SSH SSH config. Yeah, I was hitting Control-Alt-T as well too. So yeah, I wasn't. Don't know why the terminal isn't popping up. I might have been on the wrong window though. SCSH config, line 19, include. So it's trying to refer to something on line 19 and line 21. Okay, so we are over on line 19 over here. Here's the include statement. And then here is line 21. See the bottom, remember? So on line 21, and we can see all the host information. So this is what it's trying to read. And a lot of this is commented out, but there is your, here you go, like connect timeout. This is where you can set like password authentication instead of using a key. You can change the port. So instead of port 22, this is where you would configure your SSH settings, like your preferences, what you want to do. Again, this is why Linux is so like nice, right? It's if you want to change anything, just go and find the config file, alter it here, and then you're good to go. Pretty cool. So, all right, let's go back over to Windows and let's go and set up this data share now. So I've created a folder called data on the root C drive. And let's just go and create a new text file. Let's call this hello.txt. Put that over there. So now we have a piece of data on our share. So what I want to do is go and right-click this directory. Right-click data, go to properties. I'm going to go to the sharing tab, and I want to actually hit share. So this should be good, right? It's the default for administrator read-write. I'm going to hit share. And what has actually happened here is it has created the network share location for the SMB protocol to connect to it. I don't know if you can really see that right there, but it's like / hostname, / hostname / data. That's the file, that's the folder share name for the SMB protocol to connect to. Okay, so let's leave that open now. I'm going to go back inside of Linux and clear screen. And what I want to do is use a command called smbclient. And what this is effectively that. It is an FTP-like client to access SMB resources on servers. So it creates this FTP-like connection. So FTP, let's take a look and see what... I want to see if someone has a screenshot of it because I don't have it readily available over here, but... I guess this is good enough. Yeah, this one over here. Here you go. This image this is what an FTP connection looks like via the command line to another server. We can see that once we connect via FTP, it kind of creates like this new prompt, like a new command line interface. And then there are commands we can run to request resources to the server. And this is kind of like when we ran curl and we curled the API of IPFI. Well, FTP would do something similar to another server, but it would run like FTP delete, FTP like ls, instead of curl running like curl HTTP get IPFI API. So everything kind of works in these prompts. And then you send it to the server and the protocol determines how to interpret it. So I hope everyone's starting to see now, like these protocols are just language that we're using. And that's why I was trying to use that conference room analogy where you would walk in and you want to, what language do you want to speak to get to what resources you need? That's all what's happening with protocols. So smbclient is going to provide us an FTP-like protocol interface to connect to SMB resources that would look like this data folder. So let's do that. So I'm going to run smbclient with tac-u, and you'll learn these syntax as you go. I'm not always going to be looking up the man pages for you in front of you and all that stuff. I'm going to just be presenting these with the assumption now moving forward that you're comfortable looking up these types of terms and just assuming that we've done the research. So SMB client tag U, and remember administrator is the user. Administrator, and I actually want to run a tac L command. And what this is going to do, this is going to list out the available shares. So Windows IP address 10.0.19.153. Password for the administrator. There you go. So what I've done is I've issued a request via like an SMB request to like list file shares. And you can see there's a couple things here that have happened by default. By default, you're going to notice that there's this admin share, there's a C share, and an IPC share. This is going to be a little confusing at first. But what we've effectively done, so Windows actually comes, I'm pretty sure these are actually default. Like when you install locally Windows, I'm pretty sure. Not 100% sure, but I'm pretty sure. And then these types of shares are available to provide network administrative access. So what we're trying to find, when we run this command, we are listing out the shares, right? But here is the data folder. These other shares do different things. Admin, for example, is going to allow us remote access for like administrative tasks. The C share is providing us access to the entire C drive. So when we're actually connecting via SSH to another client, to another server, we're connecting because we have the ability of the C drive being shared for us. If these types of shares are not available, we would not be able to access the other workstation. SMB is very similar. SMB is looking and to see what has the workstation provided to us as a default accessible share that can be read and interpreted via SMB protocol. And in this case, SMB, if it has the C $ share enabled, then we can traverse the entire C drive directory. Now, in order for us to be able to do this, we actually have to mount the drive. Well, that's one way to do it, I should say. We want to go, and just with this default client, we want to go and mount this file share. And we want to mount it locally into the Windows directory so we can traverse it with ease. So what I'm going to do is I'm going to do make directory. I don't know what I should even call this. What did we even call it, lab? Yeah, SMB share. Okay, just so that we're consistent. SMB share. So make directory SMB share. And what I want to do here is I want to mount it and use a file system. And this is called the Common Internet File System, CIFS. This allows us to mount local network shares, or sorry, mount remote network shares and interpret it as a local file system. And CIFS, it's called common for a reason. You can pretty much mount this thing anywhere. And what we want to be able to do is just effectively use our SMB share folder and fill it temporarily with whatever is connected inside of this data folder. So I'm going to go back here and just for the sake of things, copy that actually. So sudo mount tag t, this is the Common Internet File System. And we're going to use username equals administrator. And then we had 10.0.19.153 and data. Data was the file. Data is the share, I should say, the folder share. We want to mount that locally to home, Ubuntu, SMB share. Back. Get that password. Paste it back in. Cool. Now we actually have this SMB share hooked up. And there's hello.txt. Go inside there. And if I were to do like cat hello.txt, here is the file share, providing hello.txt for us now that we've mounted it to our system. That's really cool. I know that's probably like a little bit complicated as well too, but did that kind of make sense? Yeah, totally 80s. Yeah. Yeah. I could go up here all day and just like, you could listen to me all day, but you have to do it. So I'm just trying to like prime you, and we're walking through together so you conceptually understand how these things are working, but then you have to go and physically do this. Go and actually create a file share, mount it in your Linux box, try to get it to work. I think also I'll show you. Oh yeah, Karina, there's always going to be like a little bit of a delay with Twitch. Yeah, my feed will always be out of sync with your feed with live streams. Internet's not that good yet. Especially like with chat. There's always like a chat delay when it comes to these live streams. But okay, let's also demonstrate now how to do this. 10.0.19.153, and let's actually just connect. Let's connect to the C drive. Now we're in that FTP interface. Yeah, 30, 60 seconds does sound like quite a bit. Could be a general internet issue, but it should be out of sync, like chat and what you see. So here is that FTP interface now in action. If I wanted to just traverse the file shares, excuse me, I can do this and access, like, this is the C file share. I'm at the C drive. So I could go to like CD data now. Here is hello.txt. I'll kind of show how to do that again. I'm going to go back to my home directory. And I can run smbclient and connect to those shares that we saw before. Like data, same thing, put the password in, ls. Here is the hello.txt file, ls. I can't get out because I'm now connected to the data share. Exit. Let's go to the C share itself. Password, ls. I'm now at the C directory. Now I can actually just kind of CD around. This is a different type of file share that allows full access to everything. And now I can actually go inside here and I can do like get hello.txt. Now I can download it, exit, and this is how I can traverse as well too with smbclient. This is why SMB is so wildly so popularly used. I think that's the word I'm trying to get. Is because effectively it allows us to have this is different than SSH, right? Like this gives us a very easy to use FTP-like connection and interface. Whereas SSH is good for like a quick in and out, one-off as you need, but this provides us almost like an operating system of its own. And you can build like a whole software around this as well too if you want. Like if we look at something like I can think like what, FileZilla? I remember back to old like clients I used to use. That's not a good. FTP client. Screenshots? Yeah, these are better. Here we go. Okay, so here you go. You can build software, like front-facing software like this, and all what it's doing is connecting. You can transfer information back and forth to one another with like peer-to-peer connections using SMB or using, and this is FTP, and this is why smbclient provides like an FTP-like interface, because it's nice and easy to use. So you can effectively get this type of interaction on the command line with another remote endpoint. Zeno, is the connection encrypted? Yes. So when we did the authentication, when I provided my password, I authenticated as me, and we've now established an encrypted connection amongst one another. Same thing as well would have happened. There would have been that that key exchange, or there could have been, we'll talk about other things later, but there's other types of they're called like challenge and response. There's other types of mechanisms where we can use for authentication and then provide like key exchanges back and forth and encrypt stuff. But pretty cool. That is the power. Is it safe to use public IP for the shares? No. I wouldn't do that. I wouldn't set up my home network as a public file server. That's pretty dangerous. I would use a hosting solution that can give you a public IP, and then you can set up a file server there, and then you can connect to it from your computer and upload stuff, and then let everyone else connect to it and then try to download stuff. And I say that because these FTP and file share types of software, they're notorious for having vulnerabilities where people can gain full administration to your workstation. Like, full. You've heard about these. They're called like zero-day vulnerabilities and such. So you don't want to put your network out there like that. That'd be a really bad idea. Don't do that. Now, in your home network internally, amongst one another, totally fine. You can share things back and forth. It's probably fine, unless your home network is compromised. Can't help you with that, though. Yeah. Good stuff, Karina. Back in action. Cool. Alrighty. I think that's a good spot as well too. Take another little break. I think that's the end of that. Yep. And then you could unmount the share as well too. Sorry, that's the last thing I should show. Do a little stretch after this. But yeah, the last couple commands over here, we can go and we can actually unmount the share. And actually, I think it might be good to show under the df command. Remember, we used this before to list file shares that we've been having on our system. If I did a df tac-h for like human readable format, here is my Ubuntu share, and you can see the remote share that it's actually connected to. It's not a local hard drive partition anymore. It's actually mounted as a network share here. And it's operating in memory. It's pretty cool. It's all temporary. Now, what if I were to go and do something like echo real hello side of real hello.txt. I'm going to copy this inside of SMB share. Oh. Copy real hello into SMB share. TXT. See, I get an immediate like permission denied. So it's changed in permissions now after I created that folder and I mounted it there. So if I did something like sudo, now I got real hello there. Let's go back inside of Windows, inside of the data, and now I've effectively transferred files back and forth to one another. But I needed elevated permissions. So things change once you start mounting file shares around. Permissions are a huge requirement to pay attention to. So if you're having problems trying to download or upload files, that's probably what the issue is. Now let me go back from here. I'm actually going to unmount SMB share. So if I go inside this now, you can see nothing actually exists there anymore. I've unmounted it. The folder remains, but all the data that was there is no longer on my system. But on the Windows side, it stays, because this is actually where the information lives, like on disk. Otherwise, on my system, it's just persisting mostly in memory and temporary disk location, and then it'll wipe itself after you remove the file share. So this is what happens like if you're working in IT and like sales and marketing calls and they're like, I can't access this folder, but I can access all the other folders inside of it. Well, maybe your network share messed up. Maybe they lost connection and it wasn't able to reestablish. Or maybe they're not even connected anymore. And what's happened there is the SMB client has unmounted in some way. That's all that's happened. Now, it'd be a larger issue, like if they couldn't even connect to anything else on the server, then that's probably like server authentication issues going on. Cool. SMB, like you saw how easy it was for me to set up file administration between one another, right? A couple commands. That's why Windows is using it. This is like your printers use SMB. Everything uses SMB for when it comes to like file transfer and storage. For that reason, it's that simple, that quick, and that easy to authenticate and secure. Whereas remember when I did like SCP, I had to be careful with the command. I don't want to overwrite something. It's very formatted in specific ways. Not with SMB. Nice and easy. And that's where you can get these like, that's why you have protocols for different purposes, like FTP being file transfer protocol. It allows us to do file transfer operations. It's designed for that. Just like SMP is designed similarly for it as well. All right. Okay. Let's take a break there. Maybe top off in the coffee, grab some water, a little stretch. Let's take a little bit of a breather. Okay. We are... Cool. Welcome back, everyone. Let's keep moving along. Does anyone have any questions generally, like on how the SMB connection kind of worked and whatnot? Conceptually, of course. Or I should say, is anything unclear about what we've just covered as well? You missed what FileZilla was while I was reconnecting. Brief summary. In general, how do ISPs and hosting providers provide stuff with Karina's question over there? So you missed what FileZilla was. Okay, so the reason why I was mentioning FileZilla was I wanted to demonstrate for you. FileZilla is a software front end. So it's like a GUI, right? It's a GUI front end that operates in the back end with the FTP protocol. The FTP protocol allows us to send requests from one client to a server for like file read, file close, etc., all that. And then it's just put in front of you in like a nice visual software view, so you don't have to worry about the code in the command line. That's effectively what it's doing. The reason why I'm showing you this is smbclient provides like a command line view of this. And that's what happened when I connected with like smbclient. And I connected to the C SMB share. It provided us an FTP-like view using the SMB protocol. And this allows just for like easier navigation, more operation, authentication mechanisms. It's a little more robust. Like FTP is pretty light, it's pretty basic, but smbclient allows us to operate almost like we have a remote desktop session on the command line. And this is much nicer than we saw with SSH and SCP. This is why we can go to like data, go inside here, look inside of it, download things, we can upload things. It's kind of like being on the FileZilla interface, but on the command line. And instead it's using smbclient. That's all. Xenophiles fails. So in general, how do ISPs and hosting providers provide such robust security? I mean, I don't know if that's like a general answer. They have a lot of servers, they have a lot of permissions, they have a lot of nodes in front of things. And it's just a series of constant permission checks and rules. The more you have, the better. The better encryption algorithms, which we'll learn about later, the better, etc. That's really it. That's really all. There's a lot of encryption, layers, permissions, and nodes between endpoints that filter based on rules. And I mean, like, they're not like the most secure thing in the world. That's why people say, like, just be careful what you put out outside of your network. ISPs get hacked. VPN servers get hacked. Like, look at NordVPN. There was a lot of issues around that. So CI is going for a jog. Nice. Good stuff. Jogging through the code. Cool. Okay, well, let's continue along then. We've been exposed to a lot today. Let's expose ourselves to a little bit more over here, and I think what we'll do... I think I'm actually going to do the Netcat lab first, instead of inspecting ports for the rest of today. I was hoping to get up to Nmap, but these things take time. So we'll probably continue next week with inspecting ports and Wireshark and such. But I want to show you in a walkthrough Netcat just for a little bit more demonstration of working with network activity on the command. Okay. We can come back to inspecting ports after. It'll make even actually a little bit more sense when we see it next week, I think. So, Netcat. Netcat effectively, it's a tool that allows us to act as the client or the server. That's what it is. It's a very, they call it like the Swiss Army knife for a reason. And for those of you, I'm pretty sure everyone knows what I mean by saying that, right? That's just a reference. It's called the Swiss Army knife for a reason because it can effectively do everything. It can send files, it can receive files, it can connect to websites, it can open up like remote sessions. You can effectively do everything with Netcat. So that's what we're going to do, is kind of walk through some demonstration of what it can actually provide. Now, one of the nice things about Netcat as well is that it doesn't actually rely on any protocol. And that's sort of the power that it has. If we paid attention to like ping, that's an ICMP protocol. NSLookup, all about DNS protocols. SMB client, it's only for SMB. SSH is an SSH protocol. Like, these things are all bound to a certain protocol. Netcat doesn't necessarily do that. It kind of just sends data back and forth, and you can sort of shape it to do what you need to do. All what it really does is it just opens up a raw data connection between two endpoints. How you set it up is really up to you. And that's kind of why Netcat is so powerful. You can set up a TCP connection. You can set up a UDP connection. We can do HTTP requests. We can do just about everything with Netcat. And Netcat actually lives within kernel space. And the reason why, well, not the tool itself, I should say. Let me clarify that. The tool, like the binary of itself, this command, that doesn't live in kernel space. That lives on your disk. But what Netcat does, when it creates a connection, it actually creates what's called a socket. And a socket is kind of like, it is a structure of data. It is a structure of code that is spun up and created with inside of kernel space. And then the operating system can connect to it via API calls. And this is why, so you've learned a little bit about API calls now with connecting to browsers, but your operating system makes API calls to the kernel. That's what we were talking about, like really early on, like kernel space and user space, and how the operating system would do something like file write, or like file open, or like memory allocation. And what it's doing is it's sending that message to the kernel. What it's actually doing is it's sending an API request. It's using language that we know, we can program and work with, kind of like when we did curl to IPFI. And we requested with HTTP for a JSON response, like a key value pair response. And the server did some processing for us and then sent us back the data. The operating system does the same thing. It makes an API call to the kernel. The kernel does its own thing that we don't need to care or know about, and then it sends us back what we asked for. That's what Netcat does by creating a socket. Once you run Netcat to create a connection as either the client or the server, it tells the kernel, hey, create this thing called a socket. And it's effectively what it is. Like imagine a socket on the wall that you plug like a wire into. It's the same thing. It creates this data structure inside of kernel space. And then from then on, the operating system can send calls to it. Like socket connect, socket accept, socket close, socket bind, like all this socket dot something. And then it does something inside of kernel space and it sends you back the result for you then to perform your desired operation. So, on that notion, the other protocols, the other commands, well, they don't do that. They work within a protocol that's already defined and they have their own rules and structure, kind of like we had the SSH config file. The SSH connection will refer to whatever's inside that config file for us to use. Netcat, we have to sort of like program as we go along. That's effectively what it is, and that's pretty cool. Did anyone not understand that? I hope, for those of you that have been like tracking along now in chat since the beginning, I hope that made more sense, kind of going all the way back to the beginning. If you're watching the recording, reach out on Discord, we'll try to walk you through it a little bit more. But that's kind of what's going on. I'll let you all process that for a moment. Cool. Okay. No general questions on that? Was that generally clear? I should ask. Okay, cool. Cool. All right. Let's walk through and actually demonstrate some usage with Netcat. We're going to go back and forth between Windows and Linux now. And what I want to do, let's just demonstrate things first. I'm going to... I think we have it. How do we have it set up? We start off, yeah, on Linux. We're going to go set up our Netcat listener port. And then we're going to send it over. Okay, cool. All right. So let's go inside of Linux. And we are going to use Netcat. Pretty good. Arbitrary TCP and UDP connections and listens. That's kind of effectively it too, at a high level. So we're going to do Netcat, TAC L for listen, TAC P for port, and I'm actually going to connect to port 9001 because it's got to be over 9000. Now this is actually up and running. You can see I'm at like this weird prompt. Nothing's happening right now. And the reason being is because that doesn't go anywhere yet. All I've done is I set up a Netcat listener. So I'm listening. I now have a socket that is listening and it's ready to accept some type of connection. And I'm telling it to listen on port 9001. Let's go over to Windows. And I'm going to go to my desktop. And I'm just going to go ahead inside here. Second. And I'm going to go and I'm going to type in echo under calls for aid. Put this into help.txt. And now all I really need to do, see if I try to like cat this file, but on Windows, type help.txt, like here's the output. I can type this again, But I'm going to actually pipe. I'm going to pipe that output. And I'm going to send it to Netcat. And I'm going to go and get my Linux IP, which is 10.0.21.67, to the same port, 9001. So now I've opened it up right away, and you can see, like, everything that I was like spamming around on Linux, it was just sitting there waiting for a connection. As soon as I opened it up, bam, like it received what was sitting there, but it also got my message. So if I were to do something, like I'm on the Windows side right now, I can't really like do anything because all I've done is I've just dumped standard out. Now I can go from Linux, hello from Linux, because it's listening. The connection's been open, but I can't, based on my command, I don't have any interactivity. All I've done is just send standard out, and now it's just, the terminal is hung up. It doesn't know what to do. So I can type whatever I want, but nothing's actually going to be happening over there. So let's go press Control-C. We can actually kill that connection. Kill it off. And now you can see that's gone as well. So we can also do that, I think, the other way. So I am going to go and I'm going to say netcat tac lp 9001, and I'm actually going to redirect the stream. So instead of this just dumping to the terminal, I'm going to redirect the stream to from Windows stream.txt. Let's connect again. And this time it's going to be a little bit different. I am going to just open up this. I'm going to type help.txt into that Netcat connection. Cool. Over here, you can see there's nothing dumped to standard out anymore. Then I'm just going to go and I'm going to cut off that connection. So now I should have from Windows stream.txt. Let's cat it. And it caught it. So you can actually use this to send files. You can do file transfer with Netcat just like that, like in a pinch. All you need to do is open up a data stream and then send it over. So I've opened up standard out, dumped in the output of help.txt, and the Netcat listener over here on a Linux was just waiting for whatever I was going to send. And whatever I sent, it's going to dump inside of from Windows Stream itself. So what if I did Netcat again from Windows Stream raw txt here, and what if I just did this Netcat 67 9001, hello, this is Windows, top secret message coded here, over and out. So you can see there's nothing being dumped here because I'm just feeding the stream to a file. I'm just sending standard out. So let's go and kill that connection now. Let's cat this. That's pretty cool. That's pretty cool, right? Like, this is what Netcat is doing. You're effectively just like spinning up a raw socket. You give it some requirements. You can do whatever the hell you want after that. Like, you can send files, you can send data, you can retrieve data. Literally, like, anything you can do is because you have the ability to open up a raw socket. And this is why they call it like the Swiss Army knife. This is not secure at all, by the way, Cap. This is this is all clear text. There's no encryption happening yet. We could do that. Yeah, I know. I mean, you could do this, like, if you want to go and make like an SSH connection, sure, I guess. But that's like really cool, isn't it? Super, super cool. You just have like your own raw stream. Now, if I wanted to have like a message service, like, I don't need Let me just set up a listener. And I'm going to go over here and I'm going to go back to Windows. And I'm just going to actually connect to it. Hey. This is Windows. What's up? Oh, hello there. This is Linux. Not much. Studying SOC 100-1. It's a lot. Chat is cool. Are you in? Oh, yeah, me too. I'm studying SOC 100-1. Yeah. Chat rocks. So you can like set up your own little like chat, you know? That's pretty cool. Later on, when we get to cryptography, I'll show you guys how you can actually do that. You can actually use an open source cryptography library, and you can wrap this inside of an encrypted session. And then just make sure that each of you have your keys. And then you can have some fun. Yeah, Karina, it's bidirectional. All you just need to establish is who is the listener at first. Prior clutch lessons today, yeah. This is it. This is where it's at. So, you just have to like plan out in your head like how do you want to do this? And then you can have a good time. Super cool. Now, if you really want to have some fun, check this out. I'm gonna go inside here and I'm gonna set up another. I'm gonna set up listener again, and we go inside of Windows. And what I'm gonna actually do is, does it have to be Linux and Windows? No, as long as it can run Netcat, Eric. It could be BSD, could be some embedded system. As long as you could get the Netcat binary to run on your operating system, you can do this stuff. So you can get the Unix version, you can get the Windows version. Yeah, Karina, I'll kind of show you. Maybe I'll do like a visualization for the socket in just a moment. So this is a CMD session, right? Like this is a CMD prompt. Well, I could do this again. And I can actually use an option over here of TAC-E, and I can send the cmd.exe prompt to Linux. And guess what? I'm in. I've now sent a CMD session from Netcat on Windows to Netcat on Linux. So I have this like this socket that's open, and CMD is living in the middle. That's really cool. Yeah. You start to, like, this stuff starts to get like really, really crazy real fast when you start getting into like the deeper layers of networking. So let me do some visualization and kind of like maybe show what's going on the good old iPad. So, did I really? Oh man, I think I ran out of my pencil. Oh wow. No, I ran out of my pencil ran out of battery. I forgot to charge it. No, that's not good. Damn. Can I draw my finger? I disabled that ability. Well, that's fun. Maybe I can find a diagram for you. Hopefully that pencil can charge pretty quick. I think, okay, this sort of like demonstrates for all intents and purposes what I'm trying to say. So if I'm the user, I live in user space, right? Yeah, okay, cool. Nakapa? It is actually, yeah, like this is how attacks happen. And this is why, you remember when I said to you all, I was like, you're going to see standard stream redirection happen all the time. Like the more you do this, the more you learn more about tech and IT inside of and cybersecurity. Okay, so what's happening here? Netcat, what it does is it actually tells the kernel to open up a kernel space related connection. Like the kernel creates like a block, like an object, and that object has the ability to interact with your network stack. TCP, UDP, the session layer related information in that area. It can connect, it can call like IP addresses, MAC addresses. It creates this little piece of running data, like, and lives inside of memory, and it gets access to all of those OSI model layer related informations. All the protocols, all the data, all the information. Your operating system now has the ability to tell that socket, take this connection, take this protocol, take this piece of data, and depending on how you set up that socket for Netcat to refer to, and that's the bridge. Like imagine that green arrow is effectively the connection. So the box on the left in user space is Netcat. And when you create a listener, it creates that blue rectangle here living inside of kernel space. And then it stays open. And then kernel space and user space connect back and forth through like this Netcat bridge. And that Netcat bridge handles the API calls. Like open connection, close connection, use this protocol, conceptually. Send this file, send that command. And your kernel handles all that for you. That's what Netcat is doing. It's creating this thing, and that thing is called a socket. And the socket allows you to connect with all of your OSI model related information on your network stack. That's the IP address, the port, the protocol, the TCP session or the UDP session, all that stuff. It gains access to it, and the socket has that ability. So you tell Netcat what you want that socket to use, and you can construct your own your own temporary virtual network connection. That's what the socket is doing. That's super cool. So in this case, when you set up as a Netcat listener, you create a listening socket that says, hey, I am now waiting for any connection, and all you're telling Netcat is just to wait for connections on port 9001 on your IP. And then on the Windows station, we also use Netcat to create a socket from the Windows kernel over there living in memory. And we told it to connect to the Linux IP address. So like socket.connect.ip, and then socket.connect.port is 9001, and then socket.data is cmd.exe. Send that over now as a client to a server on the Linux box. And the Netcat socket is acting as a server. And it just received that client request. And it just so happened to be that we sent it cmd.exe, which immediately executes. And we are able to then run commands locally on the Windows system as a running CMD session. And instead of standard in being the terminal, standard in becomes our Linux terminal. That's what happened. Does that make more sense? Yeah. Sorry, I wish I had the pencil recharged. Yeah. Super cool. Good. Very, very cool. We can do more. Yes, exactly, Karina. This is how you might have heard things called like reverse shells and remote code execution. This is how that happens. What you're seeing right here. This is effectively what an attack looks like, but really like hidden and crafted and coded better. But it looks like this. This is why I keep saying like networking is the thing you want to spend the most amount of time on, really understanding. Because it is this easy. And remember that the whole concept of networking, back from the ARPANET to today, it wasn't inherently designed and built with security in mind. So we're constantly trying to just find ways to wrap these connections in security. That's it. Very cool. Let's see what else we could do. There's a couple other more things we can do. We can also use Netcat to formulate HTTP requests. So let's do like something like Netcat. Let's go with something like simple example.com. We're going to connect on port 80. This is just like the convention. So it looks like what we've done right now is we've now created a network socket as a client to connect to example.com server, like the domain hosting that that web server. So I've told it that I've connected on port 80, which is an HTTP protocol. The server from example.com is expecting now HTTP code. So all I need to do is give it HTTP code. If I were to say get from like the root web server and then say 1.1, that's an HTTP protocol standard, which you can, this is just documentation. So I want to perform a get request, and the host HTTP header would be, of course, example.com in this case. Oh shit, that up, didn't I? So that failed. I made a typo. So obviously it's not like as nice as working with curl and everything, but in a pinch. There we go. I've used Netcat to create a client connection to the example.com web server on port 80. So port 80 is expecting HTTP protocol language. I gave it HTTP protocol language. I said get HTTP 1.1, host header, example.com, and it responded back with HTTP. That's the protocol in action. But I could give it any protocol I want. And as long as it's formatted properly, and the server's expecting that protocol in that port, it will then respond back in that protocol language. Karina, so if you could ask, what is the reason this Netcat stuff has to go through a socket through the operating system? Because the operating system has limited access to those resources. The kernel space is what holds access to the full network stack. The operating system does not. There's a separation for security. As you can see why. But this is an example of using Netcat as just like whatever you need it to be. Whatever you can imagine for a network connection, you can probably pull off with Netcat. Yeah, that's exactly why, Karina. It has to go and access and live inside kernel space because that's where the deepest level of hardware resources are available. Remember, the operating system is just like a visual overhead for you to interact and call the kernel. The operating system is not a socket. It has a window manager, it has a process manager, it has a terminal, it has support for your mouse and keyboard, but that's all it is. The kernel can't live inside there. The kernel has to live outside of that. The socket has to live outside of that. So that's pretty cool. Welcome to networking, everyone. Things are about to get a lot more interesting from here on out. This is where it starts to get a lot more fun. I think I'll stop there. Lots to take in. Cool. Hope everyone enjoyed the stream today. I'm going to stop there for the weekend, and we're going to pick things back up next weekend. We're going to carry right over. Now we can actually do like inspecting ports, so you can kind of see this action happening. Oh no, KS, we're doing 2 more streams of networking. Yeah, so I made some updates, and then I just need to do some Discord callouts, see what people are feeling, but next weekend is 2 more sessions of networking. We need more time. Yeah, for sure. Cool. Well, thank you everyone for spending your Sunday with me. Thank you for sticking around. I know we covered a lot, but this is what it's all about. Yeah, we've got a lot more to cover. Thank you again. Thank you for the follows and the subs. Thanks for the engagement, the fun, the participation, the good questions. And you now know how to set up some real sweet connections. You can go and set up a Netcat connection. That's some cool stuff. So thank you again. Have yourself a awesome week. We'll see you back next Saturday for another 2 sessions of SOC 100-1 networking. And the recording should be up, I guess, next couple, probably Tuesday. Yeah. Thanks again. Take care.